Hello students, in today's class we'll learn about wear loading, or in other words how much hard a gear should be. Now to understand this we have to understand some few things, how we derive the wear loading and what else is left. Main is the concept. You can derive everything what you need. It's very easy. The thing is that main is a concept and what are the procedures taken by the or obtained by the engineer by the scientist, which could help them to understand how wear occurs in gear. At first, we have to start from a point where we left actually. P efficiency. As I have told you, P efficiency is the effective efficiency, or P effective, PEFF, is the effective force what we applied over here, or in other words you may say the effective loading what we have done. And CSPT, I know this is the formula given by AGMA, again that is American Gear Manufacturing Association. So CSPT, CS and PT, I know CS is the service factor, PT is the load what is being applied and what is making actually some actions, and PD is the dynamic load. Now here comes where the dynamic forces are working. So we need to know how the dynamic forces are working, and we'll be getting to these things in very in precise manner so that we could understand it. So PD is something, this is given. So what is the effective loading? We have seen in the earlier class that what we have applied in the effective loading. So I have told you that was a type 1 example or problem. So type 4, type 3 will be getting problem within this manner. So P efficiency is nothing but the sum up of the dynamic load as well as the force applied. So what is PD? PD is equals to 21V CEB plus PT by 21V plus root over CEB plus PT. 21V means pitch line velocity, C is the deformation factor, that means how much deformation has been done and how much deformation has not been done. Now E is the your errors between the two meshing of teeth, that is sum of errors. There will be some error while meshing of teeth, that is what E is given. B is the width of the gear teeth. PT is the tangential force, or for which torque is generated. Same over here. So this provide us PD. PD is the dynamic load which help us to find out the P efficiency. Now, as I've told you, C is the deformation factor which depends on the some factors like K. The formula is given by K by 1 by EP by EG. It's the Young modulus of pinion by plus Young modulus of gear. It has been established by EGMA. Most of the things are established by EGMA. So what is K? K is the constant which depends on the formation of teeth. How much? So what will be that? That where comes your full depth, or full depth 14.5 degree or 20 degree stub teeth. So I told you as in previous that 20 degree or 20 degree, this is nothing but your pressure angle. This is the pressure angle for full depth. That means the teeth are meshing fully. One teeth is getting meshed with other teeth fully, but started it's getting meshed, but it has some criteria and many things. So at that time the formula of K changes to from 0.115, and for full depth that it remains 0.111. so the K value will be 0.11, and the Young modulus of the pinion material as well as the gear material. So we could calculate C, that means we could find out C deformation factor. We know the C. What is E? E is the error for pinion and error for gear. That is, error is the calculative error, that is numerical error, as well as the error what we make while machining and everything. That is accounted and that is put over here. Okay. B we know, say B is the pitch line velocity, we know. Okay, fine. Now the dynamic loading is also connected to something like this. It's called phi. This is a tolerance factor. Now this thing is related to this one, because I told you we'll be going for the major one more class, or the one more doubt clearing session where we'll be getting this about these things. Now dynamic loading needs this phi, this tolerance factor, because you are meshing two teeth. That means you are entering one teeth in between two other teeth. So it is something like this. If we get on this pen, it is something like this. This is, so you need some types of tolerance. You can't actually give a complete clearance. You need some tolerance, you need some clearance. So that is what is obtained by this one. Q is equals to m plus 0.25 root over d dash. D dash is the pitch circle diameter. For pinion it will be dp dash. Okay, so it depends on the material. So as well as C value, the value of C can be calculated by using this one. This give us the this is the trial and error method by AGMA, again AGMA. So it gives us the for the pinion or gear material, if it is gray cast iron, then for 14.5 degree full depth it will be 5540. Respectively for 20 degree full depth it will be 5700, and for 20 degree start depth it will be 5900. For pinion material steel and grey cast iron, similarly like this, and steel cast pinion and gear material, if both the materials are of steel, you will be getting this one. So these are all calculative and as well as tested data. So you can't change it, even neither anyone could change it. Now I heard we got about dynamic loading. That means what we have done is till the classes, the sum what you have done is up to this one. That means we have not gone through this one. We'll be getting in the future sums and problems. So that means it will provide us a dynamic loading. That means we will be getting out a dynamic loading. So we'll be doing other dynamic loading problems as well. Now the last point is, what is well loading? Well loading happens, as we know, that if we consider one body and if we scratch it one or twice, if you get an indentation, that is a scratch mark, that is what hardness means. So here comes a problem. How to get these things in easier way. So this is what we need to understand. This is gear 1 and this is gear 2. Both are meshing. Okay, and the gear diameter of gear 1 is D1 and gear diameter is D2. So they are meshing over here in this point. Like if it has been zoomed over here and it has been enlarged to see these things, that is this point to this point is 2b. Okay, and this length to this length is considered as L. It is not given in your textbooks, so you have to understand it. So okay, now since it is providing force over here, it is applying force over here, so something, this type of thing is occurring, as we know that. Can anyone tell me what type of force is it? It's a compression force, compressive. So compressive force, that means it will be sigma C. What do you know by sigma C is equals to force by area. Now comes, where did I get this from? Now I know what is force. Force is this one. Okay, what is area? So let us calculate the area. As per the ellipse is concerned, we know if this is the epicenter of the ellipse, so I could draw like this. This will be B and this will be A. Okay, so A equals to A into B into pi. So what is B over here? It will be this one. What is this? 2B by B by 2. Okay, that means from here to here. Now what is A? A is this one. What would be this? Now this amount. What is this one? This one is L by 2. Now substituting these things, this will be L by 2 into L by 2 into your L by 2 into 2b by 2 into pi. So this 2 and this 2 gets cancelled, and this 2 gets to the numerator as it is shown over here. Okay, so from this this is what happening. So what I came to know is that the area is 2 pi by bl by 2, so 2 gets over the numerator. So after rigorous practice, I mean after rigorous things and everything, every calculations and everything, we got to find out this formula also, that is b is equals to something. What is b? B is the half with the of the deformation. So this calculations give us to understand what is 2p pi. We know what is p. P is the force, mu is the friction, E1 is the your elastic modulus or modulus of elasticity or Young modulus of this one, and E2 is the elastic modulus of Young modulus of E2. D1 is the diameter of this one, D2 is the diameter of this one, pi is this pi. We know what is L. L is the axial length, that is from here to this is the axial length considered from this point to this point. So now let us we got this one, we understood this one, everything is clear. So after that, let us start a game of substitution. What is substitution over there? We know sigma c, we know this thing. So after substituting the game, how substitution game works, let us see how it works actually. The substitution game is what? This b is been calculated, or you may say that has been observed or everything from, and this had been substituted over here b. So what will happen? To remove, that's a square root form, that means b is nothing but a square root. So to eliminate the square root, we have to square it. After squaring and minimizing everything, we'll get in this form. So scientists told that what we can do, scientists came up with the value at the best value for gear, that is the best frictional coefficient it could have. It is 0.3. That's why they substituted 0.3 over here, and they got this value 0.35, p by l and everything. Now after doing this one, they came up with one thing, that there should be something which will be matching, which will actually help to calculate one thing. Now the first thing is that we have to understand one major thing. Now if we go back over here, we could see 2 cylinders are meshing, that is 2 cylinders. Okay, fine, 2 cylinders are meshing. So they while meshing, they are having also a teeth. So this is the cylinder, this is the cylinder circle, and this is the curvature of gear. What do you mean by curvature of gear? It is nothing but the radius of curvature. So they told that let us change it in terms of this one, in terms of this one. So that is what done over there. How they did. So at first of all, what they did, it was d1 by d2, that was nothing but d1 d2. So after that they reduce it to r1 by r2. After that they told that it will be not r1, it will be r1 dash, it will be r2 dash, that is it will be this one r1 dash, and it will be r2 dash. Why? Now the question comes, why they have done such things, why they have replaced or something. This has been replaced to the radius of curvature. That means, as you can see over here, that means 2 gear that is like this, and one more gear that is like this. So there is a curvature of the gear. So they have connected to the base circle like this. As you can see, they named it as R1 dash. It should be R1 dash. Why they are substituted in terms of R1 dash? Because these things, this R1 is related to R1 dash. How? The first and more, how the radius of the cylinder is dependent on the pitch circle. That is nothing but this one. Okay, this one, the pitch circle of the pinion. That means of this one. Okay, the problem starts from here. That means it depends on the pitch circle, that is the pinion. So what they have to do? They have to find, they substituted in terms of radii of curvature, such that they could actually simulate that pitch point. Now why? As you can see here, if I take it, this one is R1 and this one is R2. That means you are considering this point and this point. Okay, fine. But is this actually a cylinder, or these are the teeth which are getting meshed? Now, as we know, as we have studied in the earlier classes, that teeth are also having some curvature. As you can see over here, there is some amount of curvature. That is a curve. So we could actually relate on this. So we thought let us do this in this manner, that a curvature is connected to from this a curvature point, that is the point of this one, that is the point of contact to the the nearest tangential point of the base circle. It is connected. So they connected it and they named it as R1 dash. In book it is given R1 R2, but it is not correct. It will be R1 dash R2 dash. Why? That thing comes because this represents the radius of curvature. That is nothing but the radius of curvature. So this will work like a vector. Now let us join this line, and this forms this line, this to this line, and this line to this line. So let us this is nothing but a 90 degree. As you can see over here, it's 90 degree, and this alpha. Then what is sine alpha? What is sine alpha? Sine alpha is equals to perpendicular by base. That is opposite to alpha, that is R1 by this one. This year to year length is dp dash by dp dash. So it will get multiplied over there. Same goes for this one. As you can see, R2, this one. So we'll be getting R1 dash R2 dash. Okay, this something like this, R1 R2 dash from this curve. So we'll put over there here, and we'll replace this entire thing to here. Do you got it? This is what we have done. Now this is what we are coming to a factor called ratio factor. Why? Because we are representing over here as a ratio. So the ratio factor keeps a major dependency on the how it works and how it doesn't works. So let us consider ratio factor Q is equals to 2ZZ by ZZ by ZP. What is Z? Z is nothing but your number of teeth. of gear by number of teeth of gear plus number of teeth of pinion. So Q factor depends on this one, as well as if you are working, if you want to calculate in terms of pinion, you have to put over ZP by ZZ by ZP. The same thing remains, only there it changes, or you may, this is the same thing, because the module or the quality, the ratio factor will remain same all over two gears. Two gears are missing. That means the module is nothing but a ratio, as well as Q is also a ratio which represents same thing like ratio, same thing like module, but in other way around. The module shows in terms of dp, that is the diameter of the pitch diameter and number of teeth, and Q shows in terms of number of teeth, ratio of number of teeth. So the now and then the thing is same. So they told that okay, fine, let us substitute this substitution, okay, to over here. So they substituted and they founded this one and this one over here. So we find this one, fine. So after clearing the screen, let us start. Let us tell you one more story of substitution. How the substitution works over here. Now, as you could see that this thing is now then equal to this part. How? You could see d dash by p, d dash by g, d dash g, the d dash g plus d dash p. This is the addition, and d dash p, g, d dash c. This one is at the numerator, this one is at the this one in the numerator, and this one is the denominator. That is the lowest portion, and this is at the numerator, and this one is the denominator. That means there is nothing but reciprocal of each other. How many of you know about reciprocal? That means it's something like this: x, y, and y, x. That means x has gone to denominator and y has gone to numerator. Same, this thing has gone to numerator, and this has gone to denominator, and this has gone to numerator. That means this can be substituted by something, right? So I could bring this 2 over there, 2, and I could write this one, but that means q by 2 is equal to something like this, or reciprocal of q by 2, that is q 2 by q. Fine. That means 2 by q is equals to this one. Fine. So as I have substituted in terms of 2 by q, and I have multiplied with d dash p. So after that means this thing is equals to this thing. So I'll replace again. I'll go to the game of replacement. I'll put over this one. Fine. Now after putting this one, what I can do is I'll get this thing something like this. That means this complete r1 dash, r2 dash, r1 dash, r2 dash is equals to this one. Okay, fine. This should be dash dash. This has not been provided. This is very bad for the printing. So this should be like this. Okay, that means this should be 4 by q. That means you are substituting this entire thing over here. That means it will give you us like this thing. That means 2 into 2, 4 q d dash p sine alpha. Fine. Till then it's explained. That means I will put this will be again substituted over here. Got it? So where we have started? We have started for finding the crushing stress or the compressive stress, and we ended up with these things. We have not ended up, we'll be ending up. Now let us consider the pitch line force or pitch line force, that is the force which is acting is considered as a normal. Why? Because it's working on a this is simulated, this is considered as plane surface where a normal force is working. That's why it is represented by Pn. Okay, that's a Pn. So Pn is equal to Pt by cos alpha. How did it get to Pt by cos alpha? How? There should be some reason behind it. We can't say as a it's it came in the way it's given in the book. No, it has some reasons behind it. Let us consider Pn equals to P is equals to Pn. So what is considered as Pn? As we know, if a body or surface, a force is acting to 90 degree towards the surface, we consider as normal force, or a reaction which is getting upward at 90 degree from the surface is considered as normal reaction. So let me consider it as Pn. So at an pressure angle of alpha. So this is what I have done. Let me draw a 90 degree from here, from I'm sorry, this is, let me bring the eraser, this will be the erase, and this is erase. Okay, fine. So where is this? Okay, so let me draw a 90 degree over here. That means this is my 90 degree. Okay, so this is Pn or P, and let us consider this is to be Pt. What is Pt? As we have studied in our previous classes, the Pt is nothing but the force which drives the equations, drives the gear. So if I zoom this part, or if I enlarge this part, I find in this manner. This is Pn, this is Pt at an angle alpha. Okay, this is wrong. This should be over here. Okay, fine. I can draw over here. That's why. So this is the 90 degree. Fine. What I could find is cos alpha is equals to base by hypotenuse. Base by hypotenuse. Base is Pt and hypotenuse is Pn. Or I could write Pn is equals to Pt by cos alpha. Cos alpha. So this is what had been done over here. Fine. And uh, and one more thing is done for maximum distortion. That means for the maximum where it can be assumed that the length L from here to here will be equal to B. That means if you consider in this way, let me clear all the ink. That means it's given over here that it's from this is the epicenter of the ellipse, and this is B, and this is L. Fine. This is the center or epicenter. Now this they are telling it will be the maximum where can be happen when this will be equal to this one. That means L equals to B. That means this length will be equals to B. So what we can do, we could actually change it. L equals to B. P will be replaced by Pt by cos alpha, and we could get these things. That means sigma square will be replaced by this one. Okay, this one will be replaced by this one. This P will be replaced by this Pt by cos alpha, and L will be replaced by B. Fine. We will get sigma square equals to some equations like this. Okay. Now, this is not end of the thing. So we have to find out the stress factor. What is the let us introduce a stress factor. How could I introduce this? No, stress factor is nothing but here this K. Okay, fine. So what they told that K is nothing but K is equals to Pt by B Q D dash P. So they have deducted it over here and they wrote something like this. Okay, they've deducted this K from here and they wrote that K is equals to this much. Just rearrange this, just rearrange. So what we know, we can find that PT, that is nothing but this one, is equals to BQ P dash P BP. Now this is where it comes in wear strength. Understood? Now what is Q? As I have told you, Q is equals to the ratio of 2G to 2 times of gear teeth by gear teeth minus gear P. That depends on the what it will be plus or minus. That depends on the internal external gear. If it's an internal gear, it will be minus. If it's an external gear, it will be plus. Okay, this you have to keep it, remember, this Q depends on the internal gear or external gear. The formula remains same, only the thing changes when it's an internal or external. Internal gear will get minus and external gear will get plus. Fine. Now after that, scientists told, okay, let me shorten these things in a simpler way by putting the value of E1, E2 and after that how it brings up. So they told us that there should be something like formulations, like the formulations of standard angle, that is a standard pressure angle, that is 20 degree, and as well as the Nyman's calculations, what we have done in the previous classes of material safety and material strength, or you may tell that material science. We have done that BHN number is equals to sigma C by 0.27. That is nothing but BHN number. So how it they have deduced, and they have also deduced it was in kgf, and if you convert it in Newton millimeter and Newton per millimeter square, it will be like 0.27 or 9.81, something like this. So I know sigma C is equals to can be deduced in terms of BHN number. There is a hardness number that is taught in your material science. This thing, entire thing is replaced over here. Okay, now E1 and E2, if both are still mentioned, if both are still and alpha is 20 degree, I could get this standardization, that is BHN equals to 0.2156 BHN by 100. Now from where did I got the steel? It's written over here. In most of your classes, in most of your cases in your college, in UG level, you will get that it is considered the material of the gear is steel, but actually it is not so. It can be of tin bronze, it can be of spherical cephalodial cast iron, it may be anything. It depends on this. This is one of the table which actually explains us how it works. So if it's not a steel, if it's a cast steel, that it will change from 0.0202 that means E1 and E2 value will be 202,000. If it is a steel as considered over here, so it will be 20600. After reducing in this factor, we get the 0.156 BHN number by 100. So again, factor of safety, for calculating the factor of safety, we know that in terms of wear, we'll consider for the maximum wear to be the maximum force and PF to be the working force. Understood? This will be we will consider that the wear stress is wear force or wear stress is maximum than P effective or P efficiency, or so that's why we will be taking the ratio of both things. That means if it will come in numerator of this one, it will get the factor of safety. So this followed by this one, as we know. So this will help us to calculate your module. How? Now what is this? P effective, we know, as we have learnt in the earlier class, that P effective is equal to 16 10 to the power 6 kilowatt CS, MZ and CV. So after that we are just replacing everything. We have been replacing that. If we consider that this equations with M into M, B by M ratio, again this M will be M square Q Z P K. So what we did is we just deduce over here. we just deduce over here. We deduce this one, and this one. Okay, we have deduced this this one, this one, 3 in 1. Okay, we got this formula. That gave us the module for wear strength. That what we have done in the previous class was module for the your beam strength. It is for wear strength. Now, before getting thanks, thank you and everything, let me tell you, PT value depends in 3 criteria. Number 1, at the end of the chapter we will understand the PT value. That is, the PT value depends on the beam strength. PT value depends on the effective loading. And last but not the least, PT value also depends on wear. That means if we summarize the whole chapter, we could understand that the value of PT is the most intriguing part or the most important part for gear design, and we have to keep in mind while designing a gear that the value of the PT should be encountered or to be calculated in the proper and in the efficient way, such that we could overcome these 3 factors. That means first factor is it will qualify for beam balance, but beam strength. It will qualify for effective loading, as well it will qualify for wear loading. As we can see for wear over here, this one, fine. As well as you could see the same thing what we have done in the beam balance or beam strength. So as well as for it depends on the P effective. As you can see in the starting of our chapter, this is the P effective is dependent on PT, or we also know that P effective is equals to CS by CV into PT. So one more thing is adding over here. This is number 4. It's a dynamic loading also. Dynamic loading. So at the end of the story, what we came to know that the PT value is the most important part of this. Among it helps us to define the beam strength, effective loading, wear strength, as well as dynamic loading. This all thing is defined over PT. So PT, we have to encounter PT in great way. Thank you. And if you have a query, please ask. Please feel free to ask. You have to join my class. You can join my class over there for the notes and everything, as well as share the video with all of your friends, college friends or other college friends, and everyone, those who has been in the global crisis and can't go to the college, because it would be I think it would be a very good opportunity for them to get class in home also. Everyone of the say college or other college, everyone is welcome for the questions. Thank you, and be safe, stay home.